Hello, my dear students. Welcome to lecture number 5 on light reflection and refraction. This is Jambagi. Let me recap the previous lecture where we understood the characteristics of image formed by the plane mirror. We also got that the introductory ideas of concave and convex mirrors. In this video, I want to discuss some important terms related to thin spherical mirrors. So let me begin this lecture. Important terms related to thin spherical mirrors. We are using the term thin spherical mirrors because they are relatively smaller or thinner in their size. Therefore, we are using such terminology. To understand the concept of spherical mirrors and their image formation, these points are necessary. So, the following points are necessary to understand the image formation by the spherical mirrors. They are center of curvature. I'm introducing the terms and I will discuss those points one by one. So first one will be center of curvature again. Second, radius of curvature. Third one, pole of the mirror. Fourth one, aperture. Fifth one, principal axis. Sixth one, principal focus or focal point. And the last one, that will be focal length. So these are the terminologies we are discussing one by one. These two pictures showing concave mirror and convex mirror respectively. So concave mirror is the mirror in which the outer portion is painted and inner portion left out for reflection. So in concave mirrors, the light rays hit the surface and converge the light, and hence they are called as convergent mirrors. Convex mirror is the mirror in which the inner side is painted by that outer surface left out for reflection, and hence it is diverging the rays of light, and hence they are called as divergent mirrors too. Okay, so let us study center of curvature, radius of curvature and pole of the mirror first. Let us try to define those. First one, center of curvature. The center of imaginary sphere in which mirror is a part is known as center of curvature. It is denoted by capital C. The center of imaginary sphere in which mirror is a part is known as center of curvature. Radius of curvature is nothing but radius of the imaginary sphere in which mirror is a part. So radius of curvature is the radius of imaginary sphere in which mirror is a part. That is known to be as radius of curvature and it is denoted by capital R. Pole of the mirror. The midpoint of spherical mirror is known as pole of the mirror and it is denoted by capital P. The middle portion, the middle point of spherical mirror is taken as pole of the mirror. Let me take all three into the diagram. So for concave mirror, this is the center of curvature. That is the center of imaginary sphere. The center of imaginary sphere shown by the dotted lines in this case. And in convex mirror too, you are having the dotted points. The center of such imaginary spheres are taken as center of curvatures for concave mirror and convex mirror. The center of such imaginary sphere is taken as, and in which, keep in mind, the mirror is a part. Okay, they are nothing but center of curvatures in both of the cases. Second one is the radius of curvature. Assume there is a line, so that is nothing but radius of that circle. Here also you take it as r. So the radius of this entire imaginary sphere is taken as radius of curvature for concave mirror. Here also the radius of sphere, that is nothing but radius of curvature for convex mirror. Radius of curvature. Okay. Next one will be the pole of the mirror. So pole of the mirror is nothing but it is the midpoint. It is the midpoint of the spherical mirror. In concave mirror, this is the P or pole of the mirror. And in convex mirror, this has to be the midpoint, that is taken as pole of the mirror P. I hope you got these 3 points clear. Next one will be the aperture. The effective diameter of the spherical mirror from that the light reflects most is simply an aperture. An aperture is the effective diameter of the spherical mirror. Effective diameter of the spherical mirror from that light reflects most. The part from which the light reflects most, that effective diameter is taken as aperture. So here assume the light is reflecting from this area. The effective diameter of that is taken as aperture. Aperture is nothing but the effective diameter of the mirror from which the light reflects most, that is taken as aperture. Let us take a principal axis, principal focus and focal length one by one. First one in this case is principal axis. Overall that is 5th. Principal axis. The imaginary line joining the center of curvature C and the pole of the mirror P is taken as a principal axis. Principal axis is the imaginary line joining the center of curvature C and pole of the mirror P is taken as principal axis. Principal focus. The point on the principal axis, it is the point on the principal axis of the spherical mirror where rays of light parallel to the principal axis meet or appear to meet after reflection. After reflection, the light rays parallel to the principal axis meet or appear to meet after reflection is known as principal focus. Principal axis is denoted by CP, whereas principal focus is taken as capital F. Next one, that is focal length. The distance between pole of the mirror P and the principal focus F is known as focal length of a spherical mirror. The distance between P and capital F of a spherical mirror is taken as focal length. It is denoted by the small letter f, small case f. So let us try to get those one by one into the diagram. So the first one will be the principal axis here. So principal axis is nothing but it is the imaginary line joining the center of curvature C and the pole of the mirror P. That imaginary line is taken as principal axis. Here also it is same from this side. Okay, that is nothing but principal axis. Principal axis is the imaginary line joining center of curvature C and pole of the mirror P. That is nothing but principal axis. Next one will be the principal focus. So principal focus is nothing but it is the parallel line to the principal axis. It is the parallel line to the principal axis. After reflection, either it converges the or it crosses the point on principal axis, that is nothing but principal focus, capital F. Okay, it is in case of concave mirror. In concave mirror, the line which is parallel to the principal axis, after reflection it is going to converge at a point on principal axis, that is nothing but principal focus, or you may call it as focal point. Okay, in convex mirror again it is the line which is parallel to the principal axis. After reflection it is appear to come from a point on principal axis, that is nothing but principal focus. Or I hope you got this point clear. I repeat once again, principal focus is the line which is parallel to the principal axis. After reflection it passes through a point on principal axis. So such point is known as focal point, or you may call principal focus. Okay, and in convex case it is appear to come from that point. Okay, that is also principal focus or focal point F. And next part, that is a focal length. Focal length is the distance between principal focus F or focal point F and the pole of the mirror P. It is the distance between F and P. F and P is nothing but small letter f, that is focal length. The distance between or the length between the principal focus F and pole of the mirror P. Okay, that is nothing but focal length. It is in case of concave mirror, and in convex mirror again it is the length between F and P, principal focus F and pole of the mirror P, that is nothing but F. With all those processes, if you didn't get these points right, please make use of my WhatsApp number and try to solve. Let me recap those terms one by one. So first one is center of curvature C. Center of curvature is nothing but it is the center of imaginary sphere in which mirror is a part. Okay, you take either concave or convex. My suggestion is stick to the concave mirror part and try to focus all these points. So I am taking this as a concave mirror. I am taking it as concave mirror. So the center of the sphere in which mirror is a part, concave mirror is a part, that is taken as center of curvature. Radius of the radius of this sphere. Radius of this imaginary sphere in which mirror is a part, that is taken as a radius of curvature r. Pole of the mirror, midpoint of the mirror, that is taken as p. Pole of the mirror is the point, it is the point on or say midpoint on it is the midpoint on spherical mirror or concave mirror. In this case, the middle portion, better middle point, is the pole of the mirror. Next one will be the principal axis. Principal axis is nothing but it is the imaginary line passing through the center of curvature C and the pole of principal axis. Aperture is the one, it is the reflecting surface, the effective diameter of that in which most of light gets reflected. Most of light gets reflected. So that effective diameter of the concave mirror is taken as aperture A. Shaded line is taken as A here. So from which the most of light gets reflected. So that is about aperture A. Next one, that is principal focus. Principal focus, a ray of light hitting the concave mirror. After reflection, it passes through a point. It passes through a point on principal axis, that is nothing but principal focus F or focal point F. Okay. Focal length is the next one. It is the distance or length between F and P. Principal focus F and pole of the mirror, focal length of the mirror. With this recap, I firmly believe that 80% of these terms entered into your mind. I will stop here at this point of time, giving no confusion to the next concept. I will see you with some more videos in tomorrow's class. Till then, take care of yourselves. Bye bye.